All right, are we good to go? I guess the mic's working. That sounds great. Well, thank you for coming to listen to me talk about what we're doing at CloudFlare with nginx and Lua. My name is Graham-Cumming. I work on lots of things at to CloudFlare, but one of the things I worked on is our WAF, our Web Application Firewall, which we use to filter requests coming into us. So some people think of CloudFlare as a CDN. Some people think of us as a DDoS prevention provider. What we do is we use nginx as a reverse proxy. And there are a lot of websites that use us and pass their traffic through us. For example, if you visit Reddit, you're actually hitting a Cloudflare point of presence somewhere in the world. You're going through nginx, and then you're, depending on what the content is, it may be being served from cache, or we may be actually using nginx proxy module to go back to Reddit and pull down the page. There are a huge list of other sites that use us in that form. We use nginx for the reverse proxy, we use it for caching, we also use it for the Web Application Firewall to filter out bad requests. A lot of what we do is, perhaps when it's in the news, is around DDoS protection. That tends to happen somewhat upstream of nginx, although some of the DOS we get hit with is at the HTTP level. So when you look at the very large denial of service, the things that are in the hundreds of gigabits per second, they tend to be at layer 3, so they tend to be lots of DNS packets, lots of SYN packets, things like that. If people are trying to get a bit smarter, because we're quite good at defending against that, they will go up a level and start doing HTTP requests that might slow down the back end. So if you're running a WordPress site, for example, you'll quite often find somebody deciding to hit a particular part of your site to particularly spin the database as hard as possible. And we would use our WAF to protect against that. When I joined CloudFlare almost 3 years ago, we had a WAF that was based on Apache, not on nginx, and it was a nightmare. And that's the technical description of what it was like. It has been replaced by myself and with help from quite a few other people with something that's entirely written in Lua. And it runs entirely within nginx. So I'm going to start with a couple of thoughts. The first one is that nginx Lua OpenResty absolutely rules. Who's using nginx Lua or OpenResty here? Okay, the rest of you who aren't, it is absolutely awesome. And I say that as someone who has the bias of a C programmer who thinks that you shouldn't be using a language like Lua for anything serious. It is absolutely awesome. The other thing that makes it awesome is LuaJIT. So LuaJIT, it turns out, is extremely good at compiling code on the fly and making things perform. And these two things put together enable us to build lots of things with Lua that are needed for our service. So for example, when you visit, say, Reddit or any other site that's on us, not only are you going through nginx, obviously the core C code, but you are hitting a quite large Lua program. And that Lua program is making decisions about how to handle a request, whether to go to cache, how to redirect it to what backend. And it's really the combination of nginx Lua and LuaJIT that make this possible. And it's important to say that a big part of our business is security, but the other part of it is performance. So we can't afford to do something slow. So we can't afford here to have a large thing written in PHP that takes a long time to decide how to handle a request. So we need to get things done in under a millisecond is our goal, so that we're not adding latency to a request that comes through. And it turns out that LuaJIT does a wonderful job of this. So what it looks like when you hit the WAF is you get something like this. This is actually a simple attack which is using the shell shock attack being blocked by the WAF. Now the shell shock attack was fairly easy to filter, right? It's just open paren, close paren, space, open brace. Anything that starts with that looks pretty bad. And people were injecting that into arguments, get arguments, post arguments, HTTP headers, and things like that. And so what we have the WAF do is inspect all of those for that particular string, and if we see that, then we just say, go away, you've been blocked. And we do that inline in the request, so there's no redirecting going on here. So this could be Reddit, this happens to be my own personal website, which I use for all sorts of testing. Now, to do that, there are a number of sets of rules that we run. The most popular is a thing called OWASP, the OWASP Mod Security Core Rule Set. This is quite a large open source set of rules that is designed to protect against things like SQL injection being done against a site, cross-site scripting, various sorts of defects that are well known that it'll go looking for in different sorts of technologies like, say, WordPress or Joomla and things like that. And it's a very large, you can just go download it, it's a very large set of rules written for the Apache mod security module. Now, what's good about this is that it is fairly regularly updated and is useful. What's bad about it is it's for Apache mod security. And so we want to be able to run that. So part of what we did in our new WAF is to make it compatible with mod security. We also like to update the WAF pretty regularly. For example, the other day there was a very serious flaw in Drupal 7, which allowed you to do any old arbitrary SQL injection you liked, and is being actively exploited. If you're running Drupal 7 and you haven't updated, you probably can't log in at this point because someone's changed your admin password, because it is trivial to do with this one. So we like to add these things very rapidly. So the other side of our WAF is that we don't want to have to reboot a machine or restart a process to change something. We want to be able to add a new rule and roll it out like that. And another good example is there was a 0-day in WHMCS, which is used by web hosting companies. And again, we pushed out a rule. To get a sense of what this looks like, you've got, in the general rules for things like SQL injections, cross-site scripting, all that, we have this almost 6,000 rules that are executed. And the really bad thing about WAFs is that the worst case runtime is the typical runtime. And the reason for that is most of the time you're not being attacked. Most of the time you don't actually spot an attack, so you have to try out all the rules, right? You have to go through and say, oh, it's not a SQL injection, I'll try XSS, I'll try out remote codes, I'll try file uploads. And so this is horrible from an optimization perspective because it's not easy to kind of go, oh, we can exclude all those things. There is some of that in the WAF, but in general, you're talking about running thousands of rules and thousands of string matches and regular expressions on every request that goes through. We also have roughly 100 Cloudflare specific things we've added for particular attacks that we've seen. And we have customer specific rules. So as well as running the generic rules, we also run things that customers ask us to. So you'll see particular attacks against particular websites. For example, Anonymous might decide to attack a particular website in Spanish by inserting a particular Spanish phrase, telling people how bad they are. We will add rules for those on the fly. And so you're looking at, let's say, order of 10,000 or so string matches or regular expressions per request across every argument, every header, the body of the request. And we want to do that extremely rapidly. In fact, our goal is to do it in under a millisecond. And from our monitoring system, I grabbed this yesterday, so you can see that this is in microseconds. So this is actually how long the WAF takes to do inspection, averaged across all machines, all requests. And so it's taking between 380 and 440 microseconds. And I think this really talks to the power of LuaJIT and nginx Lua, that this is entirely a Lua process. And yet we can do this inspection. And we're doing this for billions of page views per day. So in fact, tens of billions of page views per day. So, I mean, part of this talk is really just that I think that OpenResty and LuaJIT absolutely rock. I mean, there's absolutely no doubt that in real production, at a real scale, they really work. They don't crash. They have this great performance. That doesn't mean you don't optimize. There's obviously things you can do to optimize, right, to make your code better. And there are some things it's worth knowing to be able to do that. So as I said, we started out with mod security. It's very well established, but it didn't scale. We actually couldn't run it at our scale. Basically, Apache would fall over, mod security would have problems, the latency was way too high. And I essentially rewrote mod security in Lua. So mod security has a specific language, and I rewrote it so that we can take that language and run it inside of nginx. And this is a huge advantage for us because we can run things like OWASP. We can also have a customer come along and say, we've got rules we've written for mod security, and I can just load them up. And this does scale. Agent Z, Ishwan, who's talking in the session after me, did a huge amount of optimization work, and well worth going to his talk at 11:45 if you're interested in what goes on there. And it's very, very fast. Now, to give you the sort of how the sausage is made at Cloudflare, This was the original architecture of Cloudflare, which still gives me the shakes, basically. So the green bit is what was inside a Cloudflare node. And so somebody comes in from a browser, hits nginx in reverse proxy, and we would then talk to another nginx, which talked to Apache running mod security. So copy the entire request across, the whole thing, sort of redo it. And the reason there was that nginx in front of Apache was that because Apache died so often, we actually had nginx to protect it. So nginx would be there and say, oh, I've spotted that Apache's died, I'll start returning some default response at this point. And so that was sort of a scaling protection mechanism. And the cache is where we cache things. So you can imagine that part of our business is caching static assets, so JavaScript, images, things like that. So we have these huge caches, and if necessary, we go back to the origin server. And the goal was to eliminate as much of this as possible. And what we now have as the architecture is this. We have nginx running on the front end as reverse proxy, and the WAF entirely as a Lua module loaded inside nginx. And then we talk to the cache, obviously, to get cached assets and back to the front end, back to the origin server. What's inside the WAF is actually just two Lua files. There is a thing called waf.lua, very original, which actually loads the WAF, and there is a thing called WAF core. WAF core is essentially a re-implementation of mod security in Lua. So it knows how to process mod security rules. And we dynamically load compiled Lua files. So we use Lua as a sort of assembly language. So we take from rules written in mod security's language or in our own language and compile them into Lua and then dynamically load them into nginx. And because we can dynamically load using require in Lua, it means that we can change things on the fly without restarting. So if we want to add a new rule, we want to turn something off, and this is very, very important because we give all of our customers the ability to configure this as they want. They can add their own rules, but they can also turn on or off any individual rule. So if you think about those 6,000 or so rules in OWASP, they can go in and say, no, I don't want that. Or yes, I'm using WordPress, I want that turned on. So the other thing that's happening when we're talking about the 1 millisecond time is we're making sure we've got the right configuration loaded. And again, this is something that's very, very easy to do with nginx Lua. So the actual conf, this is our actual conf file for what happens, is we use the access by Lua directive, and it loads the WAF, that waf.lua, and runs it on the request. So it's really, I mean, there's a few other things in here, but it's essentially those middle lines there. So in the access phase in nginx, we go in and say, okay, run the WAF on this and decide what to do about it. And the WAF will return either 200 or 403, depending on the request. To give you a sense of how this operates, we start out with something like this. So this thing at the top here is a mod security rule. Now, mod security rules are kind of weird looking because they are designed to be put in an Apache configuration file. So they have to meet Apache format. So they're rather odd. So basically, this one is looking at a post argument, comment underscore post underscore ID, which would be an argument, in this case in the post. And it's running a regular expression. That's what @rx means. And the regular expression is looking for, it has to be numeric, basically. So this is a good example of the sort of 6,000 things we're running. This could be done over many arguments. It could be something that's run, for example, for shell shock. We run something like this over every single argument and every header. And then it's telling it what to do about it. This is a WordPress exploit, so it's a fairly simple SQL injection thing. So it's telling it to drop it, which means the request actually gets just sent back with a 403. Now, what we do with that, well, we have that, and then we also have another way of doing it, which is we have our own language, which is at the bottom here, which is considerably easier to read, which says, this one is saying, look at the user agent. If the user agent starts with data store, and it's a get, and the URI looks like this is an actual real attack. Some people like to do, what they do is they hit a particular URL, and then they put in the URI, some number equals some number. So some random number equals some random number. So they're just trying to create random requests. And so we'll take something like that and match it and then drop that request. And you'll see this typically, especially against WordPress type sites. So what happens is when we've got these rules, we have this thing called the rule compiler, which takes that and it turns it into a gigantic piece of JSON. So the JSON just describes what's in the rule. And the point of this is that we can take rules from different inputs, so mod security or our own language or potentially other things. And after that, it gets turned into a piece of Lua code. So this is an example of what the Lua code might look like, each rule ends up being some sort of if or nested if. And so this is going through, and in this case, it's that particular regular expression I was talking about before, where it's actually looking for numbers. And there's a lot of, because this is assembly language, it's a little bit difficult to read. It's essentially assembly language, right? It's auto-generated code. And we never really look at this code unless we're doing optimization. So an example of a real example of this looks like that. So this is actually just a couple of rules, 0001 and 002, which are doing a string equals on a particular parameter and looking for a particular string. And over time, as we've done optimization, we've altered the rule compiler to change the generated code to make it faster. To give you a sense of the extent of the things you can be matching against, you can be looking at all the parts of the HTTP request, so anything in the arguments, anything in the request headers, cookies, the URI, the body of the request, and then you can be doing all sorts of matching against it. So mod security has a whole lot of matching functions like run regular expressions, look for particular words, does it have this substring, does it begin with this, end with this, pattern match, PM, which means take a whole file full of potential strings and run that whole file against it. One thing we did there, so that's kind of an interesting example, is that as part of the optimization, we discovered over time that pattern matching. So what they'll do is, for example, they'll have a whole file full of user agents, which are illegitimate, for example. And you want to take the user agent and match it. Is it any one of these? And we've actually replaced that with our own implementation of a thing called the AHO-Korosik algorithm, which is a string matching algorithm, which is extremely good at doing multiple string matches. So you've got a list of, is one of these things in this particular string? And as with a lot of stuff at CloudFlare, that's been open source, so you can go download that. It's a C++ implementation that you link into Lua and gives you very, very fast string matching. So there's all these different things. There's also things like numeric comparisons, because you may want to look at headers that have numbers in them and say, is it this particular version or is this particular thing? You can also do counting. Have you seen this thing 10 times? And as well as that, you can completely transform any string, such as a header or an argument, in different ways, like lowercasing it, removing comments, base64 decoding. So what's happening is, as you get a request coming through with this goal of 1 millisecond, there's a tremendous amount of work going on to do that pattern matching. Right? It's not just perhaps a small number of regular expressions. And we also, as I said, give the user the power to turn things on and off. So they can go and click one of these on-off buttons, and within about 3 or 4 seconds, that will actually be implemented globally. And they'll be able to just typically do a refresh in their browser and say, okay, here we go. So how do we achieve all this? Okay, so that kind of sets the scope of what we're doing. Yeah?
Any questions in between?
It's as you want, if you have a question.
You said something about the other side of the algorithm in C++.
Yes, AHO-Korosik, yeah.
Yeah, so how does that get linked into your Lua stack?
I'll show you in a minute how that works. Because towards the end, I'm going to talk about how you link C code into Lua. So the first thing we do is we start by looking at the actual rules themselves and doing optimization on the rules themselves. So the rule compiler, which we built, does things like, for example, regular expression optimization. So what you'll quite typically see is the people who write rules don't necessarily know what they're doing with regular expressions or do crazy things. And so we can, before we ever run, we can actually go through and say, this is a silly way to do that, do it a different way. We do things like operator replacement. So we'll say, why are you using a complicated regular expression for this when actually what you wanted was string contains, right? Find this string. And we also can provide hints to the WAF runtime about what work is going to be necessary. So one of the things that mod security has is a sort of macro expansion function where you can actually set a variable or a macro in a previous rule and then expand it somewhere else. It's useful to have hints about whether you should even be bothering to do that work, because there may not actually be a macro mentioned here. And there's lots of global optimization. So we can go through and we can recognize repeated use of strings or repeated functions and do that. So at the beginning, we do all that work to make sure the rules are optimal as we can from the mod security language side. And so this is just output. So for example, you see people doing a regular expression like, look at that fourth one down there, a regular expression which is the whole thing, contains possibly something. So that, that hat dot star dollar. It's like, I don't know why you do that in a regular expression. There's actually an unconditional match operator, which is this always matches. Or, using a regular expression to find get slash. Well, okay, So why don't we just use string equals? Or even regular expressions just for doing matching of an entire user agent like that. So things like that will happen automatically at runtime. But then once you've done that, you have to get into real actual optimization. So I'm going to talk about some of the things that we do. And most of what I'm going to talk about in terms of the tools we use are open source. So you can go use these for your own optimization tasks. So some basic kind of Lua optimizations, which most people who've used Lua will get familiar with. We make extensive use of regular expressions. So if we want to dig in and find out which regular expressions are hot, that can be very useful. We have some special ways of doing arrays, which gives us some performance, and I'll show you how to do that yourself. Making sure the code is actually JITable. So LuaJIT can only compile things it can compile, which is a bit of a strange thing to say, but it has a limited range of things it can actually compile. And so you want to make sure that your code actually can be actually compiled, and I'll show you what that's all about. We make extensive use of caching, of course, because we want stuff in RAM or even in CPU cache, and memoization. Well, memoization shouldn't be news to anyone who's optimizing code. So basic optimization, locals are way faster than globals. If you're doing things inside, it's far faster to make a local reference to something that is typically global. So for example, math.random, the random number generator, is actually better to, at the top of your Lua file, say local rand equals math.random, because it doesn't have to look it up in the global table. Not using the hash operator, just getting it into a variable if you're looping. Otherwise it goes around every time it has to work out the end. Using the dot syntax instead of colon is actually much faster. And in fact, much faster than that is to make a local version of things like string len, and then only use the local version, the local reference. And minimize use of closures. So up until fairly recently, LuaJIT, if you're using closures, which the original rule compiler did, tended to be a little bit slow. So we actually changed the rule compiler not to use closures. So now it's using very simple code, which is sad because I like closures, but there we go. So PCRE is the underlying regular expression engine, and using its JIT and caching options. So JIT compiling the regular expressions and also caching them so that hot regular expressions are actually already compiled makes a huge difference. And there is a directive called Lua shared dict, and this creates essentially an in-memory cache within nginx that you can then use to store things. So hot items, so loaded code, for example, that might be going to get reused, you can store in a shared dictionary, and then it's in memory, so you're not even going out to some other caching layer, it's actually right there. So one of the tools we use is a thing called a flame graph. Has anybody used these flame graphs? Okay, cool. So what the flame graph allows us to do is take an actual trace, so we take a stack trace from a running program, and then look at where time is being spent. So what we would do for optimization, and this again is a tool that's open, I'll give you the link later on, allows us to dig into where things happening. So this one is saying, if we just go up it, at the bottom it says, access by Lua, so that's in the access by Lua phase, and then it's actually running the WAF, and then you can see the various functions that are being called in the stack over time and find out where they are. So in this case, I'd highlighted the fact that string split was being used about 5% of the time. So obviously string split, why are we using string split so often? What can we do to optimize it? These output very nice SVG graphics, and you can quite easily dig into there from a running program. The tools we use for this are based on system tab. So we can actually take something that's live and system tab into it and then say, oh, what's going on? And we have some examples of that. For example, there's another view of this, which is just to say, okay, ignoring the actual trace of what's the order here, where's most time spent? And so here's an example of 15% of the time was doing regular expression matching. Well, not a surprise because we do a huge amount of it, but it's worth understanding, where is the time going? And in fact, it was interesting that 9% was in a string find. And this is actually after we had optimized the WAF a lot. And if you think about the WAF as its job is to do regular expressions and string matching, this is actually what you want. You don't want something else to be at the top of this list. It's wasting its time in housekeeping. So these tools, again, you can output. Now that's sort of, this is showing you a mixture of Lua code and C code. You can also go straight down into the C code. You can actually look at the C level, so outside of Lua level. And this is a real example of, we were seeing some bad runtimes, and it turned out that there was this particular nginx reg sub, so using a substitution with a regular expression that was taking up a lot of time. You can see it at the top there. And one of the tools we have, which allows us to do live monitoring, is this awesome thing called nginx PCRE stats. And this is actually the And it's then looking at the execution time for actual regular expressions running in that live program, which for us, because of the huge variety of traffic we have, although we have test suites that run synthetic queries through things, it's hard to say, hey, what happens in the real world when all the traffic of Reddit hits us or something. And so you can see here that most of the regular expressions were running in 2 to 4 microseconds. So that was cool, but there were some slightly slower ones. And so what we can do with this tool is we can actually dig in and say, okay, which regular expressions are taking up the most time? And there was doing so again on the same, this is again on the same process that was running. You could see that there were this strange regular expression web_attack was being executed a lot of times. So we could change how that was being used because we didn't need a regular expression for it. But this is total running time. If you notice, the total data size is fairly small there, and also this is not telling you which ones have the worst time, because it turns out these ones are being used just a lot. So these were hot, so we can go in and optimize them. The other view is which ones individually are really bad. Like there's some regular expressions, if you hit them, they're monsters. And so that, again, is worst time top here. So this was kind of interesting. There was this cookie thing here where it was looking for .cookie and then a word boundary and then a whole other thing. So what we did was actually, after having got the whole WAF running out, that we actually went in and looked at the individual regular expressions and hand-tuned them. But these tools give you the visibility. You can't really tell out of the 6,000 rules which ones are going to turn out to be bad in practice. There are some things you can, but in general. And the second one is kind of crazy. I mean, I don't know why they're using a regular expression for that particular thing. So these tools, again, if you've got something running that's using nginx and PCRE, you can just go in and attach and find out what's going on. Another example we saw was something that was spinning around inside. So we saw that string find, just the classic string find in Lua, was being used a lot. It's sort of near the top there. And we wanted to find out why. There's another tool, which is nginx LuaBT. Again, allows you to attach to a running process, and then it will start sampling it and tell you, oh, okay, this is the stack trace that's really hot. And this is nice because it gives you line numbers straight in the code. So you can say that particular loop there is really, really bad. And it turned out that there was just a pathological situation where I was looking for curly braces and it was silly the way it was being done. And it just instantly pinpointed it, and you can deal with those sorts of things. So those tools are worth going and getting. They are part of this thing, nginx system tap toolkit, which allows you to attach nginx. So you can look at things that are happening in the C land within nginx, things that are happening within the LuaJIT land. And then the Flamegraph tools are great for showing you, to taking that output and synthesizing it into something you can quickly look at. So another thing we do, so just moving on from there, is we do two-step caching. So the compiled Lua that we generate from the rule compiler is actually distributed via a thing called Kyoto Tycoon around the world, and then stored in memcached. So it's available on the machines in memcached. But because we want to get the latency to be as low as possible, we actually, once it's been loaded, we store it in a Lua shared disk in nginx itself. So we have that data available to us right there. So even on top of memcached, it was worth keeping it as local as possible. And one of the ways in which we do that is we actually use require, but we use an interface called load string. Does anyone use load string in Lua? It allows you to take a chunk of Lua code and load it as code, so it gets it compiled into Lua. Typically what you do is you'd use require with a file name. What we do is because we're not getting it from a file, it's coming from memcached. We extract it from memcached, we then load it, which gets it actually, what it does is it wraps it in a function and loads it. So now you've got a function you can call to get that code compiled, and we stuff it into the package loaded table. So package loaded is actually the list of packages that are now loaded by Lua. And by doing that, when we call the require here, Lua goes and looks it up and says, oh, I've already got that, compiles it, and we're off. And that's a little trick that allows us to control where code is being loaded from. It's not coming from a file, because the file system would be way too slow for this. And we had problems with it. And yet at the same time, we just use the standard Lua mechanisms for this and get it compiled. And we actually have a whole mechanism around this which allows us to invalidate what's in package loaded to reload something. So if we actually change a rule, something goes through the rule compiler, gets pushed out, we just say reload, and it gets reloaded live without changing anything. Okay, so I said that LuaJIT was cool. LuaJIT is a tracing compiler. So what it does is it watches execution and looks for a sequence of things in the Lua bytecode that are hot, and then compiles them into assembler. It's blindingly fast. The key is you want to make sure it can actually do that compilation, because it doesn't know how to do every single thing in the standard Lua API or everything in the bytecode. And there are some special APIs which make things cool. The key thing here is Mike Paul, who writes this, is very willing to take your money and add things for you. So CloudFlare actually sponsors him to work on performance things. So as we've seen things in the WAF that needed doing, we have sponsored him to make those changes. And so over time, there have been things that will be in LuaJIT 2.1, and so if you are using it, LuaJIT 2.1 is in Git and is pretty stable. Has a lot of performance enhancements for the sorts of things that we're doing, string matching type things. One really cool API is a thing called table new. So in LuaJIT, you can't do this in Lua, you can do require table.new, and that gives you a function which allows you to create a pre-sized table. And the reason this is cool is you don't have all the time of memory reallocation going on as you add things to a table. So if you have an idea of approximately how big your table is going to be, whether it's an array or a hash, then you can go pre-allocate it and then fill things in. And that can be a big win. So that's an example of an API which is in LuaJIT that's not in standard Lua, and the sort of things we've done. One of the tricks we do is a thing called dual use arrays. So in Lua, an array can be both a sort of numeric array, starts with 1, and a hash table as well, right? And there's quite a lot of times where we need to iterate over the array, for example, over the keys or the values. And rather than doing this using pairs, we actually basically do this trick. And the idea is that we store everything twice in the array. We store it numerically and we store it in the hash table. So for example, this little example I have here is a thing that maps the month name to the number of days in a month. So you can see that you're going to want January to have 31. And what we do is we fill in the array numerically. So we use the 0 position, which Lua doesn't use, right, because everything's 1-based, to have a count of how big the array is. So we don't even have to ever do len. So we know how many entries there are. And then, for example, here I've done days 1 is January, days 2 is 31. So each pair of entries, I and I plus 1, will be a key and a value. But we've also stored it really, so the next line where it says days 1, so it's going to say days January equals 31, means that you can both look up something by saying, days January and get 31 out, but you can also iterate numerically, jumping by 2. So this loop at the bottom, you can pull out the keys and the values without ever having to iterate across the hash table itself. And this turns out to be quite a big win. It looks kind of weird, and getting your head around. I have actually a slightly longer example here where it actually adds all of the days, and this turns out to be a big win when you're actually running through tables. And typically in Lua, you're making lots of tables with interesting things in them. So that's actually kind of a cool technique. And just to give you a sense of this, you can actually, if you're interested, with the -BL option in LuaJIT, get it to output the bytecode that it generates for a particular function, and if you then ask it for the JITted version, it can show you where it had to stop. So it'll actually say, I couldn't compile this part because, for example, this particular element is not implemented. So you've hit something that's not implemented. For example, we do a lot of string concatenation in the WAF. That was up until LuaJIT 2.1, which is not released yet, but is in Git. That was not JITable. So if you hit a concatenation, you did foo equals foo ... something, suddenly you couldn't be compiled anymore. You'd blown the trace out. So from 2.1, there's lots of things that have been, concatenation is now JITable, calling C function calls, lots of things to do with strings, and we're continuing to sponsor this, lots of things to do with tables. The goal here is that the whole thing can be turned into assembly language. You asked a question about calling a C function. So a really nice thing LuaJIT has is the foreign function interface. It allows you to call an arbitrary C API directly from Lua. I've got a simple example. This is a real example where we call get time of day to get microsecond level timing data into Lua. So you can see there this require FFI, and then there's this FFI CDEF. That's just a piece of C code that's going to get compiled right there. And then later on, there's a Lua function which uses C dot to actually call that. So you can directly call functions externally like that, and now this is also doesn't stop the tracing compiler. So this is how we link up to things like the Aho-Korosik algorithm so that we can then insert interesting bits of C code when you need to go the next level in optimization where there's an interesting algorithm. For example, we looked at, and I have it on my GitHub, doing Aho-Korosik in Lua, and it wasn't much faster than doing a whole sequence of string matches. And part of the reason that the C++ version is so good is that we have actually managed to get the table that's generated, there's a special table that's generated for matching, to be in cache on the CPU. So you get this blindingly fast string comparison. All right, did you have a question you want to ask me?
So do you discourage your customers from writing Lua and instead ask them to?
We don't let them write Lua.
CloudFlare rules that you can then compile.
Yeah, we don't let them write Lua because all of the Lua that's running is from the rule compiler, which is taking something, either the JSON intermediate form or something written in mod security and inserted like that. So we do have a sandbox where we could allow somebody to write Lua, but typically we actually have somebody in the company write it because we don't want, the Pumpkin Lady's website, which is on Cloudflare, to take down Reddit because of some pathology in the Lua code. So my closing thoughts are that this combination of things, nginx, Lua, LuaJIT, and actually PCRE, because it's JITable, absolutely rule for this sort of thing. So we run thousands of rules on every request in under a millisecond, in fact, in hundreds of microseconds, without a crazy amount of difficulty. We spend time optimizing it. We spent time thinking about it. We had the tools, the system tap tools, to look at what was happening, the PCRE tools, and you can do the same thing. Honestly, use nginx, Lua, and LuaJIT. It's awesome. Thanks. It looks like there's enough time for questions if anybody wants to ask anything. Are there questions? Yeah.
Do you run it across every MIME type or just certain MIME types?
That's a slightly complicated question. We do different things depending on the MIME type. So if it's a binary MIME type, so somebody's uploading a file, for example, we actually have a thing which is called something like really binary, I think it's called like that, and we actually peek inside to see if it's really binary, because, for example, you'll get evasion on the WAF where someone will, a very common PHP thing is, there's a thing where you upload an avatar, and you upload a PHP program, and then you actually execute it, right? That's a really common, anything to do with PHP is terrifying, but that's a sort of terrifying thing that happens. So we actually will look and say, oh, this says it's binary, is it really binary? And if it's not really binary, then we'll pass it through the WAF and say, hey, go take a look. If it looks like it really is a PNG, then we'll say, we're not going to look at regular expressions across a PNG. So we were at one point, and that was causing us all sorts of nightmares, but yeah. Yes?
So I assume you're doing some sort of logging of hits on rules?
Yes.
How do you deal with that from a performance perspective?
Oh.
Asynchronous?
Yes, so we have a thing called $store, which is a stupid name, but that's what it's called. And basically, it is a thing that we can throw log for the WAF specifically, because we have a huge logging infrastructure. For you imagine the amount of stuff that Cloudflare is doing. But for the WAF specifically, the $store, we use this thing where we create a JSON, a blob of JSON, which says what happened when we block something. And then we throw it down a UDP connection and just say, whatever, it's gone, right? So, and there's actually a whole thing we have to do with pooling of UDP and stuff like that. But yeah, that's pretty performant. That's not been an issue. And we're not logging things we didn't block. So, there's a huge percentage which gets through, right, which is good requests. On the actual logging infrastructure of Cloudflare in general, where we're logging every single request from a performance perspective, we want to know how we're performing. We're not logging the contents of the request. We're logging, oh, by the way, somebody did this and it took this many milliseconds of this thing happened, or how we decided to process it. That's billions of log lines a day. That's a whole different thing. That's actually done primarily in Go, actually.
Do you have a learning mode for your application?
We have a learning thing that's separate from the WAF. So there's a whole other security world in Cloudflare.
So how do you make sure that there are no false positives when you onboard a new application?
No, we don't, right? We don't make sure that there are false positives in the WAF. That's definitely the case. basically, if you're talking about somebody signing up for their website and turning on the WAF, I mean, they have access to all the things, what we were just talking about with the logging, all the things that were blocked. So they'll see very quickly if there's something that they think is, is something we shouldn't be blocking. Yes?
How do you pipeline in the new open rules that come out? How often and those
So we probably pipeline in stuff that we write more often than OWASP, because OWASP updates fairly infrequently, actually. In which case, that's more of almost like a software release process, because like, oh, they've updated, let's compile it, let's run some tests against it. From the point of view of, like, for example, a customer will come to us and say, please block. I don't want to hear from this user agent, or some particular thing is happening to me. We just have a process actually run using make, which will take that. We have an infrastructure that when you write a new rule, you have to write tests that go with it. And you have to write tests that are expected to pass and fail. So things that are meant to be blocked and things that aren't meant to be blocked. And so what happens is we'll compile it, we'll run it through the WAF standalone, make sure the tests all run against it. So it does the thing the customer expects. And then actually it's just a question of it being inserted into Kyoto Tycoon, and it distributes itself around the world, appears in Memcached, and within that customer's configuration, if it's a customer-specific one, when their request comes in, it'll say, oh, it needs this thing, and it goes to that loading, and it's loaded into memory. If it's something more generic, like something in OWASP has got updated, same thing pretty much happens, which is that it gets distributed out to the whole world, and there is a mechanism, which I didn't show you, which looks at the MD5 of the generated file, and if the MD5 has changed, then it triggers a reload into the Lua space. So it's actually really not very complicated in Lua. It's one of the things, and it works really nicely, and I could show you the complete code if you were interested in knowing how it does it. Yes? You know what? You would actually be better to go to Ishwan's talk at 11:45 and ask him, because he did all that work and knows it way better than I do. I could bullshit, but it'll be bullshit. So, I think, how are we doing? I guess there's a couple more minutes. Anybody? Yes.
Once you generate the code, are there any offline sort of places where you run the code to make sure it's not going to grab out?
Oh yeah. There's a test suite. So basically, there's a thing that generates all the code, and then we have this test suite that runs against it. So we know what it does, and we know it does what we expect. So the big thing with the WAF is not that it causes a problem in the sense of performance problem, because we got pretty good at the performance. It's more a question of did we accidentally block / as oops. So that hasn't happened yet. So anybody got anything else? Yeah. We do sometimes. It depends. It honestly depends whether we notice, right? So if you think about the billions of page views that go through us, the WAF will often be blocking stuff that we just never even notice, right? So with shell shock, there was just all sorts of stuff being attacked all over the place. So there's no way we had time to go tell people. But we do if we see a specific, especially what typically happens actually is a customer writes into us and says, bad things happening to my website, and then we'll say, oh, turn this rule on, because maybe they've got something disabled. For example, with the Drupal thing, there are a lot of people who use us and they have Drupal, and they didn't actually have the Drupal rules enabled. I was like, if you turn them on, you're going to discover that your life is suddenly better. So, how much? I guess we have one. Is there one more question? Yeah.
Somebody said that they can turn off the Drupal rules. So
yeah.
What are the categories like?
It could be. Yeah, the OWASP, you can do it on a per file basis within OWASP, and then on a per rule basis within OWASP. So you can go through and say, 90693, I don't like that rule, turn it off. And then we will not run it when the WAF runs. Yeah, absolutely fine grade at the single rule level. Yeah, all whole files, all whole rule sets, up to you. All right, thank you very much.